Hello everyone, today we'll be going through the Year 12 MM3 for worksheet 6. Again, the answers are on the screen, so cool, let's get started. The first one, we're studying the domain and range of f, which is this square root function here. And immediately we know that the minimum value inside the square root should be 0. And so we can kind of just let x plus y is equal to 0, then we know x is -1. So that's our smallest value for the domain. And since x can be as big as it wants, therefore the range can just go all the way up to infinity. Therefore, the domain of f is from -1 to infinity, and the range is from 0 to infinity, as when x equals -1, this function has its minimum value at y equals to 0, as we can't have a negative square root, basically. All right, the next question, show that if fg of x exists. So we can basically see first, to see if something exists, we have to see if the range of g is a subset of domain of f. So in this case, the domain of f is from -1 to infinity, and the range of g, this is just a parabola function with 1 to infinity like that. This point is 1, so the range of g is from 1 to infinity. So range of g indeed is a subset of domain f. Therefore, f of g of x exists. And now to consider the range of g, we just sub in the range of f of g, sorry. We just sub in the range of g. So the smallest value is 1. So f of 1 gives us √2. So √2 is the smallest value. And since x can go as big as it wants, that means the range can go as big as it wants. Therefore, the range of f of g is just is equal to square root 2 to infinity. And the square root 2 is inclusive. All right, C. Let h of x equal to this equation here, and we need to see if f of h exists. Again, so the domain of the domain of f is again from -1 to infinity, and the range of h is from -infinity to 8. The way I do this is that since this is a parabola, and since the coefficient of x squared is negative, therefore we know it's this shape. So we just have to work out the turning point, and we can plug in the turning point formula, which is -b on 2a, which gives us -2 on -2, which equals to 1. Therefore, it means that at x equals 1, it has its turning point. So we sub in h of 1, that gives us 8. Therefore, the range is just from -infinity to 8. So in this case, we can see that the range of h is not a subset of domain of f, as -infinity clearly isn't a part of domain of f. Therefore, f of h of x is not defined. Of course, and the next question asks us to restrict the domain such that it is defined. So since we know that range of h is from -infinity to 8, for range of h to be a subset of domain of f, we must have to restrict the range of h to -1 to 8. So that would be a part of that, and that will make it to be a part of domain of f, basically. So now we just have to find the values of x so that h of x is within -1 to 8. So a quick sketch tells us that, so this line down here is -1, this here is 8. Basically, it just tells us between -2 to 4, h of x would be within the domain of f of h of x. Therefore, we have to restrict the domain of h of x to -2 to 4. And then we just need to state the range. So in this case, we know that the range of h, which is inner functions from -1 to 8, we can just plug that into f of x. So f of -1 is 0 and f of 8 is 3. Therefore, the range of f asterisk of h of x is just from 0 to 3. All right, so question 2. We are stating the rule and the domain of f inverse of x. So we just switch x and y around and do some manipulation. We eventually get this, and don't forget to switch y into f inverse of x. And then, so we have f inverse of x is equal to 1 on, sorry, I've missed a square root here. Square root of x plus 1. And the domain of f inverse is from 0 to infinity. The way we can tell like this is that basically, since x can't be 0, right? But just by looking at this, x can't be 0 because 1 on 0 is undefined. And x can be a negative number, as square root of a negative number is also undefined. Therefore, we just know that x can be anything greater than 0. Therefore, we know the domain of f inverse of x is from 0 to infinity. And this also works with f of x, as this is also the range of this. We can just quickly graph it and check, basically. Anyway, now we can look at the sketching. So that's the two graphs sketched, basically. And so for f of x, we know that there's a vertical asymptote at x equals to 1, as x can't be 1 in this case, or it will be 1 on 0, which is undefined. Therefore, this graph here is f of x. And on the other hand, f inverse of x, well, actually, no, my bad. I drew this the opposite way. So so this is f of x down here, because it will approach this value here, which is x equals to 1. But on the other hand, we look at this, we know that since x can't be 0, that means the minimum value of this function is approaching 1, because this value can only get as small as possible, but it will never reach 1. Therefore, it will have a horizontal asymptote, sorry, at y equals to 1, and therefore this graph here would be f inverse of x. And to work out the intersection point, you just solve any of these equal to x, because they always intersect at y equals x. And on the Kaiser, I actually got a rational value. Correct me if I'm wrong, but I'm pretty sure the intersection point is irrational and can't be expressed as an exact value. But correct me if I'm wrong. But what I've got is 1.7549 and 1.7549. So that'll be this question. And for question 3, this is a simple it's a product rule combined with chain rule question. So to do this, the answer is there, but I'll quickly work it out. So because this is, let's say this is f of x, and we'll call this part g of x. The product rule is just f of x, g dash of x, plus g of x times f dash of x. So in this case, it will just be x squared times 3 times e to the power of 3x plus 2x times e to the power of 3x, which is what I've got here. It's just I moved the 3 to the front and then swap the 2 all around. So basically that's the answer for this. And keep in mind, we do not need to factor out the 3 e to the power of 3x. Like, that's whichever form you express your final answering is up to you. But yeah, in a case like this, we don't have to factor out the e to the power of 3x, and that in an exam at least. For the next one, this is a chain rule question. So to find f dash of 1, we first need to find f dash of x. And when we see f of x equal to log of something, log e of something, then we know that generally, if we want to find the derivative of log e of anything inside, like f of x inside, this is just equal to f dash of x on f of x. Sorry, there's no dash here, so f dash of x on f of x. So f dash of x in here, it will be 2x, and f of x is x squared plus 2, so that's the derivative. We start being x equals to 1, we get f of 1 is 2 on 3. All right, cool. That's all the answers for the worksheet this week. If you have any questions, please let me know in the Wait chat, or you can ask me in the Math Study Hub, which runs every Tuesday from 6:30 to 8:30.